Now, let's learn more about indicators and how they can be utilized to distinguish acids and bases. So here, as you can see, I have taken three different test tubes, and in the first test tube there is hydrochloric acid, and the second one NaOH, sodium hydroxide, that is a base, and in the last test tube there is water, H2O. So here, in order to make you understand how we can detect the acidity or basicity of a particular substance by using a litmus paper, I am taking a blue litmus paper and I placed that blue litmus paper in hydrochloric acid solution. And when this blue litmus paper is dipped in this hydrochloric acid solution, obviously the blue color of the litmus paper will change to red color. And I take this red colored litmus paper and I put it in the NaOH solution, that is, which is a base, sodium hydroxide. And when I place that red colored litmus paper in NaOH solution, that red color changed to blue color. Because in a basic solution, red colored litmus paper turns to blue, and in an acidic solution, blue colored litmus paper turns to red. Now, I take this exactly same blue colored litmus paper and I dipped it in water. No change had happened because water is a neutral solution. And now, litmus paper is a natural indicator. There are artificial or synthetic indicators as well. The first important artificial indicator is phenolphthalein. Here, as you can see, phenolphthalein is a colorless liquid that is utilized as an indicator. And when this phenolphthalein is added in an acid substance, it will remain as colorless itself. And when we add this phenolphthalein in a basic solution, the colorless nature of phenolphthalein will turn to pink color. And by changing or by identifying, by observing that color change, we can easily distinguish acid and base by using the artificial indicator named phenolphthalein. Second one is methyl orange. It is also an indicator. And when methyl orange is added in an acidic substance, as you can see, the color of the acid will turn to a pinkish red color. And when the same methyl orange is added in a basic substance, that base or the basic substance color will turn to yellow. In this way, by utilizing the synthetic indicators or artificial indicators like phenolphthalein and methyl orange, we can distinguish acids and bases. Now let's see some more examples. First one is hydrochloric acid. And here we are using different types of indicators, both natural as well as artificial. And let's see what are the changes going to happen. So, hydrochloric acid, red litmus paper. When a red litmus paper is dipped in an acid, there is no change is going to happen because only an acid. When a blue litmus paper is placed in an acid, the blue is going to turn to red. When a red litmus paper is dipped in an acid, there is no change going to happen. That is, no changes happening. H2SO4, that is sulfuric acid, again acid. When dipped red litmus paper, no change. HNO3, nitric acid, CH3COOH, acetic acid, all the acids. When we dip red litmus paper in any acid, we will not observe any change. But on the other hand, we take some sodium hydroxide. As I told you earlier, sodium hydroxide is a basic substance. So I take this red litmus paper and dipped in sodium hydroxide, which is a base. Obviously, that red color of the litmus paper will turn to blue. Not only sodium hydroxide, whatever be the bases, all the bases, when dipped a red litmus paper, the bases, as a result of the interaction of the bases, the color of the red litmus paper will turn to blue. That is, we are taking calcium hydroxide, red litmus paper again turns to blue. We are taking potassium hydroxide, again changing to blue, and magnesium hydroxide and ammonium hydroxide, all they are giving blue colored litmus paper. That is, they are turning red colored litmus paper to blue. Now, we are taking blue litmus paper and we are dipping it in different types of acids. We know that blue colored litmus paper, when dipped in an acid, will turn to red color. So, whether it is hydrochloric acid or whether it is sulfuric acid or nitric acid or acetic acid, the blue litmus paper will turn to red color. Now, the blue litmus paper, when dipped in basic solution, there is no change going to happen. Only red litmus paper dipped in basic solution will turn to blue. When a blue litmus paper is dipped in basic solution, no change is going to happen. Whatever be the base, there will be no change happening to the color of the blue litmus paper. Whether it is sodium hydroxide or calcium hydroxide or potassium hydroxide or magnesium hydroxide or ammonium hydroxide, whatever it may be, when a blue litmus paper is dipped in a base, no change is going to happen. So, we have completed the natural indicators part. We have tested various acids and bases with natural indicators. Now we can shift to phenolphthalein and methyl orange, which are artificial indicators. Phenolphthalein, when used in an acid, there will be going to no change. That means colorless phenolphthalein will remain as colorless itself. So, in all the acids here, as you can see, when phenolphthalein is added, it will be colorless itself. But when phenolphthalein is added to a base, the colorless phenolphthalein will convert to a pink color, pink to red color ranging from pink to red. All the bases will give us pink to red color. And now methyl orange. Methyl orange, when we add this methyl orange in acid, what we are going to get is a pinkish red color. So if I take something in my hand and I wanted to know whether it is acid or base, I just added 1 or 2 drops of methyl orange to it. And if it is giving a pinkish red color, then without any doubt we can say that it is an acid. So all the acids react with methyl orange to give pinkish red color. Now let's see what is going to happen when a methyl orange is added to a base. When basic substances are treated with methyl orange, we are going to get an yellow color. All the basic substances, when treated with a methyl orange, we will get yellow color. And this is how we are distinguishing acids and bases using natural as well as artificial indicators.